Hi, everybody, and welcome once again to Mondays with Mike. You'll find this each Monday on fox26houston.com and as well as YouTube, Facebook, Twitter, all that good stuff each Monday, where sort of gives me a chance, 15, 20 minutes-ish, sort of share with you what I'm thinking for the week. You know, a lot of times it's weather and science related. Sometimes it could be something random like sports, which of course we're all pulling for the Astros. But today I'm very excited and I want to share with you, we have a lot of technological, tools here at our disposal as your Gulf Coast Weather Authority. For example, we have our own 1 million watt radar with dual polarity. We also have the latest and greatest software and hardware from the two primary weather vendors in the world of weather. Got a lot going on. But what I have to introduce you to today is something I'm very excited about. Are you ready? What could it be? It's a dry erase board. Yes. I'm excited about this because sometimes, now this was purchased here by the station, so thank you very much, Fox 26, at the suggestion of my colleague, Lena Maria Arango, one of our other fine meteorologists. And she said, wouldn't it be great if we could just have like a whiteboard, a dry erase board, because sometimes things happen or you want to explain something and there's either no need or no time to construct, a graphic in the weather system to sort of explain some concepts or things like that. So I thought it was a great idea, and the folks down the hallway thought it was a good enough idea to go to Staples and drop a few bucks on it. So this is our dry erase board, and anyway, I'm going to use it for some illustration today about something that I came across this weekend. And it is an important topic, sort of a serious topic, and we are talking about climate change / global warming, and something that the White House, as well as some other researchers around the world, are going to put some time over the next few years into studying, okay, how to combat it. Let me just start by saying there is a difference between global warming and climate change, okay? Global warming is the warming of the planet due to, it could be human-made or it could be natural processes that trap more heat in the atmosphere, okay? So that's global warming. Climate change is something that's been happening forever, right? I mean, since the dawn of time, since we've had an atmosphere, the climate's been going up and down and up and down. We've had ice ages, we've had hot spells, we've had ice ages. So we all know that. The concern now is what has mankind done to change those natural processes? And this is completely 100% apolitical, and it's just going to be talking about science, okay? So this is not a political thing at all. So what I came across this weekend that I wanted to bring to your attention that I thought was really interesting was something that sounds like something that like Lex Luthor would come up with, but it's coming from, I think their heart is in the right place. And it is the concept of injecting aerosols into the stratosphere to block sunlight. Okay, so let's just talk about this using the whiteboard, which I'm excited about. So now all this is being done on the spot, and I'm going to tell you, I am not an artist. I'm not a very good artist, but hopefully this will do. Okay, so this is the Earth, the beautiful blue, almost sphere that is in our solar system that we happen to live on. Okay, we know that. Now, we have the sun, which I don't have a yellow marker. What am I going to do for the sun? Let's make the sun red, like the Krypton's sun. So let's just say we have. This is called incoming solar radiation, ISR, or it could be called incoming shortwave radiation, ISR. And what it means is that you have energy that comes from the sun that actually is mostly in the form of visible light, the light that we can see. That's short wave, okay? It also comes in the form of ultraviolet radiation, which is why you can get sunburned, and it also affects the stratosphere, which we're going to be talking a lot about here in a moment. So you have this incoming radiation. Then the Earth holds on to some of that warmth, and it re-emits what is called long wave radiation, which is infrared. Okay, so you have this energy coming in from the sun, and then it does a lot of different things to the Earth. You know, it causes clouds, it causes, the warming of deserts, the warming of the ocean. It differentially heats the Earth so that you have colder weather at the poles and hotter weather at the tropics. I mean, it creates all of the weather and climate that we all know and love and all have to deal with. What you want is for everything to be in equilibrium, okay? So we call that energy balance, okay? There's what's called an energy budget, in the Earth, but what we want is balance, okay? B-A-L-A-N-C-E, I think that's how you spell it, balance. So if you have the same amount, roughly the same amount of energy coming in and the same amount of energy going out, then you're in balance. Then you don't have any global warming. You're not going to have any influence of climate change really from this scenario because everything's in balance, okay? But what happens if you have this much radiation coming in and now all of a sudden you only have that much going out? And that's imbalance, okay? So we're no longer in balance. And that's the problem that we're having right now, which is why you hear so much about global warming, so much about climate change, and it gets to the point where it's like, enough already, right? But this is the scenario that we're in, and there are a lot of natural processes that cause this, okay? There are a lot of natural, volcanoes affect the climate. Forest fires affect the climate. Changes in ocean currents affect the climate. But the reason that this is a problem for us is that in this case, a lot of it is caused by man, okay? So if you were to take this, let me get rid of this, okay? So you have what I would call, and I don't know if this is the technical term for it, but you have new carbon and old carbon, okay? New carbon and old carbon. So new carbon, let's see, new C, carbon, and then old C, okay? New C, if we release that, new carbon, it's okay. It's not great, but it's okay because it's new. And we're talking about like wood, okay, trees. Let's say you start a bonfire, okay? So, you have this fire and you're burning wood. Well, that wood is like, how old is the wood? Maybe it's 20 years old. So the carbon that is released as carbon dioxide, which is a greenhouse gas, it's new, okay? It was taken out of the atmosphere like 20 years ago or over the course of the last 20 years, and now you're releasing it. So that's not the problem, okay? So let's say this is like, 10 years to maybe 50 years old, okay? What's the problem is with old carbon, okay? So this is oil. This is nat gas. This is coal. Okay? Why is that a problem? Well, because these, okay, hopefully it's not, these are millions of years old. Millions of years. So that is why it is such a big deal. People say, well, gosh, it's not our fault, the climate's always changed, and that's correct. The climate has always changed, and it will continue to change. But the thing is, we're playing a role in it right now because we're taking old carbon and we're releasing it into the atmosphere as carbon dioxide now. So you had all of this carbon dioxide that was in the atmosphere 50 million years ago, or 70 million years ago, or however many million years ago. That was a sink, okay? It was removed from the atmosphere. Now we're releasing it all of a sudden over the last 100 years. So you took millions of years worth, and now you're releasing it over 100 years. And so that's the problem. So anyway, you have this problem with pollutants that are called greenhouse gases, and you've probably heard of them. They are CO2, which is carbon dioxide. There's methane, which comes from livestock and other, industrial processes. You have water vapor, okay? Vapor. Come on now. You have water vapor. And then you have things like the other oxides, sulfur oxides, and nitrogen oxides that are air pollutants. So, get to the point, Mike. What's this paper? What were you talking about? Well, this is where it gets interesting and controversial, okay? So, what are the ways that we can stop it? Okay. Well, we can completely stop burning fossil fuels. Okay, so we'll put fossil fuels and we'll completely stop that, which puts us into the Stone Age immediately. Why do I say that? Well, because as much as people want to glue themselves to the wall in Dutch art galleries, if we stopped all fossil fuel production and burning right now, we would have no food because we use it as fertilizer. We use it for tractors to till the fields and to harvest the food. We use it to feed animals so that we can eat the animals. We use it for fishing so that we can eat the fish. I mean, it's like you can't just stop all of the sudden burning fossil fuels. It's not even worth talking about because it's dumb. You can't, okay? As much as you want to glue yourself to a wall and throw soup on a Van Gogh painting, you can't, okay? The other thing you can do is to lower this, okay, the fossil fuels, okay, and then that's better, okay, but slow. Maybe too slow. Maybe if we just cut back on fossil fuels, maybe there's still going to be some climate catastrophe. I personally don't think that's true, but some researchers do, and I'm sure you'll agree with me that the more dire a scenario, the scarier a scenario is, the more media attention it gets, okay? I'm not saying it's not an issue. I'm just saying maybe it's not an existential threat like tomorrow, okay? So, but this is what I wanted to talk about today, and I'm finally getting around to it 15 minutes into my little broadcast here. And that is what's coming out of the White House. So the White House, this is a great article by a lady named Catherine Clifford, who is a journalist who covers climate and technology-related matters. And she writes that the White House Office of Science and Technology Policy, the OSTP, is conducting a 5-year research plan into injecting aerosols into the stratosphere to effectively block sunlight. So you have the Earth. I'm just going to draw like a semicircle here. So here's the Earth, okay? And then above the Earth, you have the atmosphere, okay? Not to scale, I say that because this would be like paper thin. But in the lower parts of the atmosphere, okay, you have our weather. We live in what's called the troposphere. So down here, this is where you have clouds, and you have rainstorms, and you have, hurricanes, and you have tornadoes, and you have, everything that we live and breathe and all of that stuff happens here in the troposphere. Okay? Troposphere. Now, above the troposphere is the stratosphere. Okay? We're just going to call this strat. Now, if you're into guitars, you'll know that a Strat is a guitar also. And it's Stratocaster is like from the same word as stratosphere. That's where it got its. That's where Leo Fender got the name for it. I just dropped my black marker. Get to the point, Mike. The point is that one of the ways that's been proposed to slow down global warming is what I think is a terrible idea, but I'm not making the decisions, right? And it's a form of geoengineering where it's proposed, okay, that you would take aerosols. What is an aerosol? An aerosol is a suspended droplet or like a dust particle. It's like a tiny, tiny little, like imagine fog. That's kind of like an aerosol, or like a bunch of dust, that's kind of floating in the air would be an example of aerosols. Real, real small, fine dust. So if you were to go way up here into the stratosphere and put these aerosols there, just a little bit, then the thought is that, well, you have that radiation coming from the sun, right? Like I said, that visible and infrared light coming in from the sun. Well, now you're going to bounce some of that off. And by bouncing some of it off, less energy will make it to the surface of the Earth, therefore less warming. Which, by the way, how do you do this? Well, there's several proposed ways to do it that I was reading up on. Oh, by the way, what would the aerosol be made out of? Controversial. What a lot of scientists propose is using what are called sulfur oxides or sulfur dioxides. Okay, sulfur dioxide is proposed because it occurs naturally in the atmosphere due to volcanoes. Okay, so we know that volcanoes change the climate, right? All the time. Like we've heard about these big volcanic eruptions that happened hundreds of years ago, and it caused back in the medieval times, it caused like the year without a summer, that kind of thing, mini ice age. So, you have this volcano that, it spews sulfur, dust, and, lots of stuff into the atmosphere, but some of it makes it up here into the stratosphere, okay? And it stays up there for a long time, years sometimes. And it blocks some of the sunlight. So what the White House is studying now, again, a 5-year study, and what they're doing is they're taking you can actually go to climate.gov, I believe it is, and you can sign up for an account and give your opinion on why this is a good idea or a bad idea. And I think they're looking for mostly scientific feedback, but maybe, the layperson can maybe give some input as well. There are a couple of other ways that scientists have proposed to block sunlight. One of them is here in the troposphere, where all of our clouds are and everything. You have these, you have clouds that are over the tropics, okay? Big billowy, like cumulus clouds, big billowy clouds. And if you make them shinier, it sounds ridiculous, but if you make them shinier, then they will also allow sunlight to bounce off of them and to go back out into space. How do you make them shinier? Well, you can spray them with things like, probably the least dangerous thing would be salt. you create like a spray of sea salt. I don't think that idea would work, but it's an idea. And then the other idea is that between the troposphere and the stratosphere, like right here, you have clouds that are cirrus clouds. Cirrus. And cirrus clouds tend to trap heat near the surface instead of letting it go back out into space. And so thinning the cirrus clouds, which I also think is a ridiculously horrible idea, that would also cause some cooling. So those are three of the ways that scientists have come up with to limit the incoming shortwave radiation from the sun. However, it says here, you may be asking, and probably are screaming at the screen right now, this is ridiculous. You know, how do they even know what effect this is going to have on things? And isn't this dangerous? And aren't they spraying us with chemicals anyway? Kind of. Okay, the scientists even admit that these sulfur oxides, the sulfur dioxide that they're talking about spraying into the stratosphere, creates acid rain. Okay, that's what we had back in the 80s, 70s, where there were forests that were being, killed because, the trees were being killed because of acidic rain. And the acid rain was caused by sulfur compounds that were rising up into the atmosphere from industry, smokestacks and everything, and getting into the raindrops. The raindrops form on that aerosol, and it makes a sulfuric acid which you don't really want falling out of the sky. So that's one of the problems. If you make this out of some sulfur dioxide or sulfur oxide compound, then if it begins to precipitate out of the stratosphere, because the stratosphere is stable. Stratosphere, it's a little confusing, but like the troposphere, as you go up in altitude, it gets colder and colder. Stratosphere, as you go up, it gets warmer and warmer because of the ozone layer that absorbs light from the sun. The consequence of that is that the stratosphere is very stable, and if you shoot something up there, it would stay up there for a long time, a lot of years. But if that stuff that they want to spray up there, if that eventually trickles back down, it could create acid rain. It also, by the way, these sulfur oxides can cause respiratory illness. So, you know me, I'm like a myth buster, and I'm somebody who is not at all, I don't like, I like a good conspiracy theory as much as the next guy, but I'm not really into chemtrails and all that stuff, because I think it's kind of ridiculous. But this is actually real, and it's not happening that we know of yet, but a lot of these scientists here that are quoted in the article are very, very serious about doing this. And the way they frame it is this. They frame the argument as if we don't do something drastic about the climate, it's going to go past a tipping point, and it's going to be the end of the world. And now there are a lot of other scientists that would say that that's ridiculous, but like I mentioned a few minutes ago, those aren't the ones that end up on TV or in articles. Most of the time it's the people that are saying that we're all going to die. So what do you think? Let me know. If you're watching on Facebook, if you're watching on YouTube, if you've stayed with me through these 23 minutes, which I really hope you have, what do you think? Do you think that the climate threat is bad enough that we have to do something really drastic? And that includes what is called geoengineering and injecting things into the stratosphere. By the way, how would we get it into the stratosphere? I'm glad you asked that question. So, and this is the last thing. I promise I'll let you go after this. I promise. Okay? There's 3 proposed ways of doing it. Okay? So here's the Earth. Okay? Here's the buildings, and here's where we live. There's a car. Okay? So this is the Earth. That's the worst car ever. That's the worst car in the history of cars. Okay? We'll put a tree. So here's the Earth, and here's where they want to put the particles. So there's 3 ways I read about that are proposed. One is that you fly an airplane up here. Okay? You fly an airplane specialized airplane that can manage flying into the stratosphere, because most airplanes do not fly in the stratosphere. Like if you're taking a flight from Houston to New York or something, or New York to London, you're not flying in the stratosphere. You're flying near the stratosphere, but you're flying in the upper part of the troposphere. So you do need a certain airplane that's capable of flying into the stratosphere, and then you can, drop the aerosols out of the plane. Another way is that they want to tether a balloon, big balloon, kind of like a weather balloon, that you would launch from the ground, and then it would have some sort of mechanism to release, and you would release it into the stratosphere that way from the balloon. The third way to do it, this was my favorite, was some form of artillery. I'm not making it up. Like either a rocket or some form of a giant cannon kind of thing, where you would have this, rocket or some sort of spacecraft, that would go up into space and then would release the aerosols that way. Okay, we're going to put a little USA on there. So these are some of the proposed ways to send the aerosols into the stratosphere. And there also are, finally, it doesn't have to be sulfur dioxide. Some people have mentioned like an aluminum compound that's more reflective, or a titanium. So all those are possibilities, but they're not going to do it like today or tomorrow, hopefully. They're going to take years and years to study this, but the way things seem to be going politically, it seems like somebody's going to do it. It may not be us. It may be the European Union that does it, because they seem to be leaning more that way. So I just wanted to bring it to your attention, but let me know. Let me know what you think. I know this was a lot. I know this was like, come on, Mike, I didn't sign up for this. I'm just trying to watch a video. But I thought it was really interesting. I read a lot on it this past weekend, and I wanted to bring it to your attention, because if you hear it coming up on TV at some point, you're going to say, oh, Mike told me about that. So that's it. So should we put aerosols into the stratosphere to block the sun? Let me know about it. This has been Mondays with Mike. I know it's a really long one, but I'm all excited about my whiteboard, so that's why it took so long. Hope to see you next week. Thanks for staying with me. Make sure to like and comment. Nice comments.